Have you ever written software to a deadline? If you're a working programmer, almost certainly. We need this software by the end of the quarter, by the end of the sprint, by the end of the day. The worst deadline I ever had was, you're on call, it's 3 a.m, and this has to be working by the time people start coming into the office. That was a very bad night that I'd rather forget. But just for this week, I think we all have to concede that we don't really know what a deadline is. My guest this week is Sam Aaron, and he measures his software deadlines in seconds. Or more accurately, in bars of music. Because he's a live coding performance DJ. He gets up on stage with his laptop, with a programming environment he created, and he writes some code that describes the music he's currently hearing in his head, and he ships it into production, the nightclub floor where people are dancing, and he does that again and again the whole night long. I've been to a few of his gigs, and he has a cracking act, and you wouldn't need to know that it's all driven by a programmer who's designing code, implementing it, and shipping to prod every 4 bars. How on earth do you learn to do that? I mean, what kind of programming language would you design to ship with that kind of velocity and that kind of fluidity? And what kind of language would you design with sufficient expressive power to make whatever music you're hearing in your head? And what takes your career from being a computer science researcher at Cambridge to being the coder that's playing a banging set in a nightclub in Berlin? Let's find out. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Sam Aaron. Joining me today is Sam Aaron. Sam, I am delighted to welcome you to the show.
Hi, it's really lovely to be here.
I've been trying to organise this since when I first started Developer Voices, I drew up a list of people I want on the show, and you were on the original list.
That's super kind.
It's taken you too long to get your house built and get over here.
Yes, shockingly too long, yes.
Yeah, probably not your first priority in how long is it taking me to get my house built. But, okay, we need to get into this. So I first encountered you at a closure conference
a long time ago,
more than 10 years ago, when you were a researcher at Cambridge, computer science researcher at Cambridge, which is very much not what your career is at the moment. So how did you get from where you were to where you are today?
It's a very good question. I mean, being a researcher at Cambridge was also part of the journey as well. I mean, I took the journey of doing an undergraduate degree at university, then a PhD, and then I was an industry programmer for a couple of years, 3 years or so in Amsterdam. And then I took a year out as a sabbatical because I never really had this idea of a year out. Lots of other people had done it before they went to their university degrees. They sort of went traveling around the world, and I never did that. So I thought it'd be really nice to spend a year out and work on my weird ideas of musical programming languages. So at the time I was working in Clojure, working on a system called Overtone with my friend Jeff Rose, who I met in Amsterdam whilst I was living there. Okay. And then my wife got a scholarship to do a PhD in Cambridge, which is like one of those amazing things you run straight forwards towards, and you don't give up. And so we moved to Cambridge, and I thought it'd be a really nice idea to spend a year in this sort of year out trying to find a way to explore these ideas about programming music and Clojure. And then after that year, then go and find a normal job and go back to being a programmer again. So it'd be quite a fun thing to do. And somehow I ended up having a desk at the computer labs at Cambridge just through the conversations I was having. And I met a guy in the music department who I asked maybe I could do a master's in music. And he was like, oh, no, you don't have enough musical background. I was like, totally fine. We said, but I do know somebody in the computer labs who actually might be interested in the work you're doing. And when I discussed it, it was this chap called Alan Blackwell. He was actually really, really excited, interested, and said, look, there's a spare desk there. You can have that desk and then let's chat and let's do some writing together and work on stuff together. And that then turned out to me then spending 8 years actually at the computer labs. Oh, wow. So kind of just fell into place. It was super weird.
When you say let's do some writing together, what kind of writing were you? I mean, are you talking about academic writing or writing
absolutely.
music?
Academic papers, yeah. I mean, because the work I was doing was very much in line with the work he was doing. He was very interested in the psychology of programming languages and I was looking at programming languages in terms of performance and as a instrument, as a means of expression. He had done work in the so-called cognitive dimensions of programming, so the idea of exploring programming languages in terms of the different dimensions like viscosity. How hard is it to think about something? Does it flow through your mind quickly, or does it treacle? And so he was trying to explore programming languages in different kind of ways that we normally think about them. Normally we talk about is it completely accurate? Is it provable? Is it speed? Is it fast? How much memory does it consume? These are sort of classical engineering approaches to exploring and perceiving programming languages, and he was taking much more of a psychological approach. And so there was definitely an overlap and an interest.
That instantly makes me think of like live coding, right? Viscosity. Brand new idea in the programming world for me. But yeah, when you're live coding, you want something to flow very quickly.
100%. I mean, so when I was talking about these ideas, he was like, they were obvious to him, and he'd been working quite closely with other live coders before. So this was very, very, very natural for him. But obviously for me, these were new thoughts I was having myself independently. And so it was really wonderful to actually meet others who had been thinking about these kind of ideas for quite a while, and to learn from them and to collaborate. It was brilliant.
Well, that's what the academic world is supposed to be, right?
It was fabulous. Yeah.
Can I just ask, how much of a musical background did you have?
That's a very good question. I mean, it depends how you define it. Certainly not on any kind of like academic level. I mean, I did study I played the clarinet in a wind band, in the county wind band, and I played in the school jazz band, saxophone. So in the school level, I was active as a musician, but when I got to university, I stopped because I wasn't as good as everybody else. It seemed like all the bands that were forming and all the orchestras were forming at university were all the top level musicians, and there was nothing really for sort of rubbishy, fun, people having a good time kind of musicians that I could find. It's a bit like with the sports was the same. I quite liked playing football a bit, but I'm rubbish at it. And so I was struggling to find people who were also rubbish, who just wanted to kick around a bit. Everyone was just really keen, you know. So I stuck to the things I was keen on, which was programming, and kind of pushed aside the music.
But it came back just because you thought you were doing a sabbatical?
Oh, no. So, I mean, I've always been curious about music. I've been listening, a very active listener. I think that's a really important part of music itself. And then I started exploring the idea of what would it be like. I mean, I was at a conference in Denmark, even well before the closure conference we met, and they had an after party, and they just basically got a bunch of programmers who could play instruments and said, "Let's form a band, and you can be the entertainment." And it was kind of a fun thing to do, but it really, I was like, it could be a bit better. And I was thinking, like, what would be the better approach? And obviously, in my head, being strange, it's like, well, surely we're at a programming language conference. Surely we should be able to program the music, the entertainment. And so that was my first thought about that. And then, of course, as soon as you start exploring ideas, you'll realize that everyone's done this for hundreds of years already. So certainly with programming and music, I mean, computers and music were a combination before computers even existed. So so that was really interesting to then explore all the people who were doing this at the time and in the past, and seeing whether their journeys and looking at the different systems. And that got me to discover SuperCollider, which is still pretty much the predominant open source synthesis engine used in pretty much all the live coding systems that aren't web-based.
So define that for me, just for everyone else. Like, what's it actually doing, and what's it not doing? Where do you come in on the boundaries? Yes, SuperCollider.
Oh, so SuperCollider is like it's an amazing piece of technology. James McCartney wrote it about 30 years ago, so it's got quite a heritage. And the idea was, I mean, up to that point that he wrote SuperCollider, most of the music systems were kind of like a render-based system. It's a bit like Toy Story, where you might have a wireframe image of all the characters, and then you would send that to a render farm, and then a week later you'd get your scene. With all the lighting all put in. Music was kind of like that, so that the computers weren't fast enough to be able to render the music in real time. So you had a lot of systems that allowed you to compose, to design the synthesizers, and then press the render button. And then some period later, depending on the speed of the machine and obviously the complexity of the system, of the audio system you're working with, and obviously of the language that was generating that, you would get some audio file back that you could listen to and go, oh, that's not what I wanted, and around that cycle it would go again. So SuperCollider was pretty much, I think, the first system to focus purely on what can we do in real time. And so the design was all about that.
So I have to check you on that, because I remember going back about 30 years ago, surely we had home consoles that were playing music live.
Yes. I mean, so I had a Spectrum, and you could write it as a basic programming language. Yeah.
So what's the difference here?
Yeah, it's a good question. So I think the main difference is that those, something like the Commodore 64 had a specific chip in it, which was the synthesizer.
Yeah.
And so you would be sending timing signals to that synthesizer to trigger it. And I mean, the SID chip's so famous that they pulled it out and they made synthesizers out of it since. And with SuperCollider, you've got both that. You've got the thing which can generate the timing signals to trigger the synthesizer, but also the synthesizer itself, the synthesis, is all done in real time using little C functions. The sine waves and the low-pass filters and the reverb filters and all of the different components that generate the sound were all running in real time. And so that had put on quite a lot of constraints on what kind of complexity of audio could you create. It was much more limited than what other systems could do, which allowed rendering, but also had this interesting property of you can do it all live.
Are you saying this was... I'm now trying to figure out why you felt the need to build something on top of that. What was the interface to SuperCollider? And were you not happy with it?
Yeah, so the SuperCollider had originally was a programming language and audio synthesis engine rolled into one. That was version 1 and 2. And then version 3, James separated them into two separate systems, the language runtime and the synthesis engine. And the idea was that he developed this language, which was his own little language. It was like small talky Ruby-like language. And he wanted also to allow others to explore what it would be like to write music systems in other languages. And so by putting a hard division between the language runtime and the synthesis engine and making an API, network API, to talk between the two, you could then essentially plug in another programming language and drive this thing in the same way you could drive a web service, say. And so I, at the time, had been experimenting quite a bunch with Ruby. This was like just before I discovered Clojure, and I'd been writing some systems. And I think probably A, because my programming skills weren't that great, and B, because I discovered that certainly the kind of programming systems I wanted to write involved a high degree of concurrency. That certainly the two of those combined to make the kind of programs I was writing really not very good, not very efficient, and not work particularly well. And so when I discovered that SuperCollider was essentially a Ruby-like language, I was like, well, maybe I want to try something else. And at that point, I'd discovered Rich Hickey and Clojure, and the idea of concurrency was something that blew my mind. It was a beautiful concept that at the time of my life was like, this is perfect. This is like a really neat way, clean way to describe the concurrency problems that I was trying to deal with and solve at the time for my early sort of Ruby systems. That I was like, this is, and also the flexibility. The things that attracted me to Ruby was the fact it's such a malleable programming language that you can treat like clay, and you can morph it into the kind of system that's close to the way you think about it. So go back to that viscosity thing. Like you can make it low viscosity in terms of the programming language and your mind are at the same level of abstraction if you do the right things. And so Lisps and Clojure as a Lisp has that property too. So that excited me. So I had the concurrency and the malleability, and I was like, yes, this is good. So I wonder if I can combine Clojure and SuperCollider. And then I discovered that one of my friends said that there's a guy that just started this project just last month, and that was Jeff Rose. And he also happened to live in Amsterdam, so we made instant friends, and we hacked on this thing together. So yeah, so it was more like I wanted to move away from Ruby at the time, and SuperCollider felt like Ruby, the programming language. And so I wanted to explore Clojure and functional Lisps particularly.
And are we talking about concurrency as being important because you're trying to write a program that is a drummer at the same time as it's a bass player?
Precisely, yeah. I mean, that's the way to think about it, like a band. Yeah. It's way more natural to think of a band of individual instrumentalists than it is to think about the single person attempting to play all instruments concurrently. I mean, that's the joke, isn't it? The one-person band is like a comedy act. It's not a real sensible approach.
Have you just given a damning review of your own act?
Well, so I mean, that if you've given, I mean, I guess I'm not the one-person band trying to play all the instruments at the same time. I'm more like a plate spinner. I've got multiple plates spinning at the same time, and I'm going and wobbling them and keeping them going. So it's really the music's not generated by me; it's generated by the plates spinning, and I'm just making sure they're keeping going.
Okay, so we've got to get into the design of how you get from that research enclosure to being a live spinner of musical plates.
Yeah, I mean, what happened with the university is that, as always with the case, contracts are hard to find and funding is always hard to come by. And there was a point where that was coming to a bit of a struggle. So I was like, I'm going to go back to being an industry programmer again. And that's the same year that the Raspberry Pi span out of the labs. And they were looking, the foundation particularly, was looking for some software to help children learn how to code. And because sense. My contract was ending and I'd worked on this weird music stuff, I kind of put my hand up and said, well, I could, because it was only for 3 months, this project. I could hang around for another 3 months and see if I could build a minified version of Overtone to run specifically on the Raspberry Pi. And maybe we could use that to teach kids how to code. And they're like, cool. So that extended my period because that was wildly successful, and they kept funding that on and on and on for a few more years.
That's instantly going to seem tricky to me because you've got SuperCollider, which sounds like it uses a bunch of resources. You've got Clojure running on the JVM, which I'm not sure I'd be able to get the JVM on an original Raspberry Pi. Yeah,
there were two challenges. So the first of all was getting SuperCollider running on the Raspberry Pi. That was not trivial. Compiling it wasn't easy. I ended up getting some support from a random internet person who just said, I'm seeing you. I wrote some blog articles about trying to do this. And he sent me some compile flags and I used them and it compiled. So it was great. So I got a working version of SuperCollider. But yeah, the JVM support at the time was extremely nascent and wasn't really well supported. And also my Clojure code was clearly rubbish. Going back, this is a standard theme for my coding skills. And so yeah, the namespaces for Overtone took 7 minutes to boot on the Raspberry Pi. So they did work, but so it was like going back to the old Spectrum days of putting a cassette in and waiting 7 minutes for the game to load.
Yeah. So
and I had 3 months for this project. So I was hoping I could just get that working and then build a little small DSL in Clojure. That was the plan. But once I realized that the JVM and Clojure particularly weren't going to fly, I dropped back into Ruby and built a really small prototype using that just to get started, and built the smallest, simplest thing I could possibly build. It took me 2 weeks to build the first version. So this was the system called Sonic Pi that I'm still using today.
Yes. So what could that first version do that you managed to put together in 3 months?
So, I mean, I kind of cheated in the sense that the synthesizers I used were all the Overtone ones. So because I've been working on Overtone for a while, I had developed a library of cool sounds, and I was able to just pull those across. So that was great. And then all I needed to do was build a language which was allowed me to teach the basics of computer science as was defined by the UK computer science curriculum. And that's really just sequential programming, conditionals, data structures, algorithmic thinking. And these are all actually pretty easy to teach when you've got a very simple programming language which has sort of statements that go through time, and those statements do something interesting. And so all I needed to do was to get it to make a beep. So that was a play command, and you could choose a note to play, and then to sleep for some amount of time, and then make another beep. With those two commands, you can actually make all of Western music. That was pretty crazy. But in the same way, like with a logo, if you've got pen down, pen up, rotate, and forward, you can draw any picture. So you've got, like, with if you've got the right simple building blocks, show me the means of abstraction and the means of combination. That's what structured interpretation computer programmers talk about. Sussman and Abelson. If you've got the right means of abstraction and the right means of combination, you can have a very expressive system. And just play and sleep were actually really great to get started. I could teach sequential programming. We can make bass lines. We can make melodies, it was great to get started with that approach. Then chuck in some if statements, and you've got some conditionals in there. Yeah, it was really quite great way of getting started. And all I needed was that, because then I worked with a fabulous teacher. She was called Carrie Ann Philbin, and she was teaching in a school in Dagenham in London. And every week I'd go and help her teach the computer science lesson. And then at the end of the lesson, we'd have a chat about how it went. And then we'd say, what should we work on? What should we teach next week? And then we'd discuss it. And then I would then go away and build a new version of the system for that next.
For the next week's class?
Yeah, weekly iterations.
Oh,
Sprints,
wow.
what they want to call them. So that was a great way of working. So all I needed to do was to have enough for this week's lesson, and then I would work on the next version for the next week and just keep iterating that way.
So at this stage, are you thinking this is just a project? Let me not use the word just. At this stage, are you thinking this is a project for how I can help teach kids coding? Or do you also have ambitions to turn this into your live instrument?
Oh, not at all. I mean, it was just a tool for teaching how to code and engagement. And at the time, I was still working very much on Overtone. And I was touring around the world at conferences, performing at conferences in all sorts of interesting venues and nightclubs and large halls and all sorts of great stuff. So,
okay, hang on, you've skipped a huge chunk then. If you're already touring as a coding musician,
so that was my going back to the time in Denmark, that conference. It's like I want to be able to do this. I want to be able to perform on stage. So that was the goal. So the side quest was always, can I build a system that allowed me to be expressive enough to be able to perform music by writing code? Is that even a thing I could do? And obviously it was a thing you could do because there were definitely others doing it at the time. It's just, was it something I could do? And could I write a system that was natural for me to work with? And so, Overtone became that system.
So originally you were using Clojure for live gigs?
Absolutely, yeah. Right, and I had a problem though. I had that. It was really hard to switch out of developer mode and to move into performer practice mode. So I would sit down and say, right, I'm going to do some making music, and so I'd open up Emacs and I'd start hacking away, and 2 seconds later, I'm like, it'd be really cool if I had this feature. And so I started working on this feature. And then the practice session would go, and it would be an absolute disaster. So I knew I needed to change something. I didn't have the discipline to not code features. So the idea was, if I could find somebody who wasn't a programmer, who was interested in working with me on this stuff, we could meet up and we could talk just about the music bits. And then I could go away and program the features we wanted later on. But in the moments we're meeting, we would only do music. So luckily, my brother-in-law, he was actually quite interested. And there was an opportunity for him to come and see my kids. So he came around every week and we went to a coffee shop and we sat down with our laptops, plugged them together. And I taught him how to open up Emacs and to shell into my machine with a Clojure, and then he was able to then run in my namespace on my machine. We were able to collaborate together, and we created a band called MetaX, which is the shortcut for Emacs, the magic shortcut.
Was he a programmer?
No, he is now, interestingly, but he wasn't. He was a chemist. So it worked really well because it did exactly what I wanted. It was provided a context which didn't involve programming as the focal conversational point. So I had to explain to him in sort of layman's terms almost how the system worked and how to operate it. And we talked about musical ideas predominantly, not about coding ideas. And that really forced me into that, out of my comfort zone, into a space where it was exactly what I wanted. And then we actually, as MetaX, did a lot of different conferences and even music festivals.
Really?
It was super fun, yeah.
So what are you learning there as a language designer? Like, if you're switching between someone who needs to write a programming language or a tool set and someone who's trying to use it on stage in front of a few hundred people? Yeah,
I mean, so it's about figuring out what aspects of the system to expose, to talk about. There's multiple facets to it. So it's not just about what could I explain to a non-programmer, but also what could a non-programmer and me, even being a programmer, because this is also out my comfort zone, do in a live setting. Like, I don't know when you see a conference talk where they do some live coding, and it's not necessarily music making, it's just, here's a website I'm building, and I've made some blog posts or whatever. Yeah. If they haven't actually, the developer knows what they're doing, but hasn't actually practiced that, it can be really awkward and really difficult.
Yeah, I think every programmer's had that experience when they're like typing happily away, and then someone looks at them typing, and their ability to even type disappears.
Goes away. Yeah. So it's like there's a performative element that needs to be practiced and drilled in, and people I don't think they recognise that enough. And so, having a language which actually is considerate of that, in addition to being considerate of the fact that they're not necessarily an established programmer, it was really critical. So it was really easy with the Lisps. You can take the complex things, you can make them to simple forms, you make the shortcuts, teach the shortcuts. Do this shortcut and it will evaluate this line. Here are the lines, here are the things we can modify. And then we will sit down and we will practice and practice and practice. And you can't get away from that. And through the practice and through finding a way together, we ended up doing some really nice things. We got onto radio stations and performed all over the world. It was brilliant.
And are you when you say practicing, are you like drilling specific songs the way a band might, or is this more freeform? Is it more jazz?
Yeah, it's more like jazz, I think. So we would send up certainly we would try and separate the practice sessions into like free form. Let's just see what happens. Let's not worry about the quality of the sound, how it sounds. Let it just be noisy. Let's just explore the space. Mm-hmm. And then when we found interesting bits that we liked, we pointed it out and we sort of wrote them down and we put them into another file and saved them. And then we tried to figure out, let's actually go, let's do a set now. Let's do 15 minutes. And let's just try and make it sound as good as possible. And so that's what we do. So we'd have this exploratory phases and sort of more performance practice phases, and try to make those performance practice phases longer and longer. So it was 15 minutes, 20 minutes, half an hour.
Right, yeah.
Can we do a 40-minute set, for example?
Were you not at all tempted to just like save those good bits to a file and then show up to a gig and press play?
Well, no, I wasn't. I think that this comes like to the same question I get often, which is like, why don't you get the AI, some large language model to write the code for you to make the music? The goal has always been, at least for me, to express myself. So for my musical thoughts to come from my brain through some symbolic representation into the computer, then out to the speakers. And then for me to be able to hear that, and then to be able to go, I'd like to go over there, and then figure out what symbolic manipulation I need to do, do that through whatever means, and then have the audio come out of the speakers and take me hopefully in that direction. And so it was really more of a conversation. I didn't if I give a talk, I don't ever have a score. Sorry, like a script of what to say. I always improvise because it feels natural. And so the same was always, for me, what you would do as a musician is just to improvise. And it was just more fun. And also it turned out actually to be really, really important because different musical spaces have different musical properties and different acoustic properties. And also different audiences have different expectations. And so if you went in and had exactly the right thing prepared, you'd have to be really sure it's going to work in that space for that audience. Whereas if you were prepared and able and capable of improvising, you could listen and see if it's working, see if it's resonating, and if it's not, you could change it and keep changing it until it does resonate and keep it there. And this was no different than giving workshops in programming. I gave Clojure programming language workshops to companies, and I'd do the same. I'd rock up with no slides. And there were like some companies would be actually quite annoyed, and it's like they're sort of affronted at the start. And they said, look, it's okay. Trust me. We don't trust you when we need the slides. And I just opened the REPL and said, right, so this is what we started. And they could soon realize that they could actually ask questions straight away. And I could experiment and show them the answers through that conversation, through the fact that I understood what I was teaching. That was a critical part. Yeah. And that I was able to flexibly move within that space in a very fluid way that facilitated the conversation. And they were able to learn much more effectively than if I just rocked up with slides and just read the slides out, which is what they were expecting.
Yeah, and I can totally get that. I mean, I do something similar with this podcast, right? I don't give you a list of questions beforehand. I want to see where the conversation's going. But were you showing up to a gig thinking, I'll play Sam's tune number 3 as an opener, and then we'll see if the crowd is ready for Sam's tune number 8 or something?
Yeah, well, so we had, so it was me. So it was, there was Meta-X's tune. It wasn't just me, right? So,
but do you have a sort of proto set list in mind when you show up?
Yeah, so we would have things we practiced that we knew sounded nice, and that we'd have themes that we'd be able to work within and spaces. So that's kind of more like jazz. So you'd have like sort of concepts, and then you'd be able to then stick at that concept for a while until it didn't sound so great, and then you could move on to the next concept. So that was a critical thing. So like, it wasn't just completely made up all the time. There were spaces that we knew sounded good, and we knew how to transition from some space into some other spaces. But there was definitely a large amount left open for improvisation at the time.
Okay, so I want to get into how.
So this was with Jonathan Graham. I was just saying that the chap.
I want to get into how you code for that, but first, haven't you just? You're saying concurrency is important. It sounds like you've solved the concurrency problem by getting a second musician back into the room.
Yeah, well, so working with a system that allowed concurrency as well, so that Clojure really provided the semantics to safely, not just safely in terms of like proof, but safely in terms of separation of concern. So we didn't have to think about clobbering state. There was always a clear way to define what the separation was, and the language provided that. Mm. So it was totally fine for him to be running his Emacs code on my computer, evaluating the code, essentially, creating threads, spawning threads, and wait for them to interlock and to work together. They're all part of the language design. So that was critical for timing as well, to make sure that the different threads didn't just run concurrently. They ran, because that's just like complete freeform jazz. You don't want that. Concurrency is not enough for music. You also, unless you just do freeform jazz. If you want a band to be playing rhythmically in time with each other, so then those threads need to not just be running at the same time; they need to be running in time.
Yeah, so, synchronized concurrency.
Yeah, having ways to coordinate the threads across, that was critical. But these are all things I could implement myself and in my own programming time, and make those abstractions for the band, so that we didn't have to think about that during the performance.
Okay, I definitely want to get in under the hood and talk about how you solve those sorts of problems. But first, I mean, what's the live? You must be one of the world's experts on live coding and what works for a live coding system, because you regularly ship code to production in 4 bars time, right?
Yes, I mean, I've done it for quite a long time. Yeah. Yes, there are many others doing some amazing things too.
But let's put you on a pedestal for a second, because I think it's very impressive. What have you learned since those early days of what makes a live coding system fluid enough that you can improvise while 100 people are watching you?
Good question. I mean, I think that actually the lessons I learned when I was exploring Sonic Pi really probably formalized those. So with Overtone, I was trying to build the most expressive, powerful programming system, like I was imagining I was a wizard. I was like electric coming out of my hands, using the power of macros, and I was like, what cool stuff could I build? And I wasn't ever concerned with how complex this is, because if I could understand it, that was fine. Like, because it was a tool for me. I'm building my own power gloves, and so I'm going to use the most fancy stuff that I can master and I can control. And it did turn out to be a bit of an issue when people came up and asked, like, how do I get this? They'd see my performance and say, how do I get the same setup? And it'd be tricky, like to get them to scratch. And there was all sorts of issues. The fact that they had to learn Clojure and they had to learn SuperCollider and Synthesis Design. And I was using a really weird esoteric Emacs config, which was called Emacs Live, that I designed. But that was what I was doing, and that was where I felt that my artistic performance and credibility was all behind. And then when I started the Sonic Pi project as a side quest, a 3-month initially side quest, just I'll stick around in the labs for a bit longer, do some cool stuff with the Raspberry Pi computer. That seems like a pretty cool thing that's just popped out. And that turned out to be quite successful, and that kept bringing in more funding, and that kept me sort of working on live coding systems rather than going back to an industry job. I still had very much this separation of Sonic Pi, toy, teaching computer science, Overtone, powerful power gloves as a wizard. And then I got an opportunity to work with a whole bunch of different artists with the Arts Council. They funded this really cool project. And they funded a whole bunch of artists to make music videos with Sonic Pi, running on this Raspberry Pi. And there was an amazing array of wildly different performances, recordings. And they're online somewhere. I can find those. But they also gave me some money also to make a music video. I'm like, oh, okay, that's a bit annoying because I actually want to use overtone, and this music video is specifically to run on Sonic Pi. But it's kind of like eat your own dog food. Okay, if all these other artists are doing it, I surely should be able to do something.
Yeah.
And so I put it off and put it off and put it off, like I do with everything, until the last minute, and the pressure was just intense. And so I just sat down and locked myself in a room because it was a week later from when I started the deadline. And so I just locked myself in a room with this Raspberry Pi and a small projector I bought that was projecting on the wall because I didn't have a monitor at home, just had my laptop. So I used a small projector as the monitor and sat on the floor and just coded this music. And for the first few days, it was horrible. I really didn't like this because it was just nothing really worked. It was very too simplistic and all very toy-like because it was all designed to teach computer science in schools. It wasn't designed to be like the overtone thing I was pleased and excited to work with.
Yeah.
But actually, halfway through, something clicked. And it fundamentally changed my relationship with live coding systems. And I think this is the reason why I'm saying all this is I think it answers your question, or it sort of goes towards that. Because it turned out that all of the design I'd put into Sonic Pi to make it simple to teach computer science in schools also translated beautifully to making a system which was cognitively simple to work with, at least for me. And although as a sort of wearing my mathematician philosopher's hat, I could see that the expressiveness, the expressive potential of overtone was much vaster than the expressive potential of Sonic Pi. So use an analogy, I got a car. If overtone's a car, it can drive over all manners of terrain and drive much further. Whereas Sonic Pi is a much simpler car that can only go on roads, say, or very simple surfaces, and has a much limited range. That range is only a potential, and that potential comes at a cost, and that comes at a cost of time and effort. And so in order to use overtone although I could imagine making a system or a sound or a weird, distributed, interesting musical instrument with multiple computers working together. And I can imagine all this and design it in my head. To build it would take months, years. Similarly, if I imagined a composition that was sophisticated, to actually realize that sophisticated composition would take hours, weeks. And with Sonic Pi, although you couldn't travel as far, its expressiveness was limited, what you could do in a smaller period of time was much, much, much more vast. And so that was much more interesting. So that, for me, that's what live coding system, at least for me, is like what can you express in 20 seconds, 30 seconds? And acknowledging that you need to compromise the expressibility of the program in terms of a timeless perspective. So like, given an infinite amount of time, what could you express? That's interesting mathematically, but it's not that interesting when you're in front of 1,000 people and you're performing.
Yeah.
What's more interesting is what can I express in 20 seconds? What's the range of programs I can write?
So do you then find that when you're writing music live and performing live, that you make simpler musical choices, but that are more reactive to what's going on in the room?
So when you say simpler, I would probably translate that to higher abstraction. So it has maybe more of a dramatic effect. I'm not necessarily designing the synthesizers live. I'm manipulating them at that low level. I'm working much more macro scale. And so simpler in the sense that I'm moving larger shapes around rather than doing lots of detail. But you can obviously zoom in or zoom out as you need to for the performance. But I tend to be much more natural at a sort of a more zoomed out scale. So not as zoomed out as a DJ where I'm putting track A and then track B and mixing them together. I'm much more of a micro level, but not micro that I'm playing an individual instrument and manipulating the timbre of just one of my clarinets, say. I'm working at a much more macro scale.
Yeah, and you certainly don't show up to a gig like building your own synthesizer as a prelude to...
People do that, and then it's amazing. Like that's an amazing skill. But the chances of actually it going wrong and horrible sounds coming out of the speakers is quite high. There's like a high risk factor. That's another. There's so many examples of features I added that made it sense in schools that also worked inside a music environment. So the kids would always as soon as they realized they could change the amplitude of a sound with an integer, So they could say AMP2 for twice as loud. Of course, they're going to do AMP 2 billion trillion zillion, right? That's what they're going to do, and add as many zeros as possible. And so adding a sound limiter and a compressor on the end of the audio chain made sense to save the children's ears. And these also make sense in a sort of a musical environment. So you don't have to think so much about the mixing. It sort of gets compressed. It might sound not great, but all these ideas that translate from one to the other, yeah.
That sounds like it's at its best, but do you not find... I mean, it seems like at its worst, you might find that the code that you're allowing children to write reliably makes what you're trying to do live more toyish?
That's a very, very interesting point. So I think that comes down to... it sounds similar to a lot of conversations I've had over the years, and it's a lot. And it's really weird to me that... a lot of people think that because a system is simple for 10-year-old children, which Sonic Pi is designed for, it's designed to teach 10-year-old children how to code. And also it's designed to work with teachers who have rarely done a computer science degree. That's the reality. And so you need something that's really, really approachable, that just boots, double click, and it works, and it's all very, very nice and friendly. People somehow think that a system like that therefore can't do complex things. And it's pretty wild to me. But the reality is that most programming languages for children that I've observed do have that property. They do have kind of a glass ceiling baked into the system. And that glass ceiling enables them to make things simpler. And it feels like that's kind of like what you're alluding to. And I think that that definitely is a real thing in a lot of design systems. And I personally... maybe sort of shaking some branches in the wrong way here. I feel that's lazy. I feel that it's entirely possible to put the design effort in to not just make it simple for a 10-year-old child, but also enable it to be expressive. To not have that glass ceiling be required. So like you have got to have the big inflatable tubes down the bowling alley so that you can ball bounces around. Like I feel like with enough thinking and thought and care and design, you're able to do both. And there are examples of this everywhere, in the same way that you can have scripts for films that are catered to both an adult and a child audience. It would be much easier to do one or the other, but to do both at the same time, if with enough thought, it's possible, and the benefits are there. So any Pixar film has adults and children laughing at different moments. That's a beautiful thing. And then coming back to instruments, because this is really the obvious one, is that people going to the idea that something can't be complicated and simple at the same time. Well, what's a guitar? And what's a piano? Now, these are very, very simple systems. The piano is just a bunch of keys that you can press. And if no one's seen if you haven't seen a piano before, I can teach you how to play every note on that piano pretty quickly. You know? Same with the guitar. I can teach you how to strum every string, and I can teach you how to place your finger on the fretboard and press, and you can change the notes. I know it might be a bit tricky, and you might struggle a bit, but you can certainly start. And then I'll show you a virtuosic pianist or a virtuosic guitarist, and you'll go, "Oh my goodness, what I can do with this instrument is just unfathomable. I hadn't realized the range of sounds and styles of music I could produce with this one instrument is just so amazing." And that's because I believe the guitar wasn't just invented, like someone didn't come and make a guitar. It's evolved over many hundreds of years, and it evolved alongside practice, alongside teaching, and the instrument sort of got better at being easy to learn and expressive at the same time. And so that instrument evolved. And the same with the piano. Piano didn't just pop into existence. It's a whole lineage of instruments that came into the piano. And so I think that we're very early in the days of live coding, certainly with music. And so I think that we're really yet to see the exciting things. But certainly the idea that you can build something that is both powerful and expressive and simple isn't to me a fantasy. It's a definite reality and definitely something to chase for. And that's what I've been chasing with Sonic Pi. And so I really honestly believe that Sonic Pi is both simple for teaching, that was its goal, but also really powerful and expressive. And I know it can do those things, but marketing it and communicating that to others is actually really, really tricky. People like the live coding systems which look like the Matrix, They like the live coding systems, which are really hard to install. I've got to download all these terminal things. I've got to run the whatever commands and pull this language in. I've got to download this complex mathematical language, whatever.
Yeah.
And that can sound all quite fun and an adventure, but it doesn't necessarily mean that the language is any better or more expressive. It's just there's a challenge or a goal to installing it, somehow makes it feel better. There's a psychological aspect.
Yeah. So the synthesizers with more knobs look more exciting, but are they more musical?
Exactly. I mean, you've got this with the Eurorack modules. So these are the synthesizers that, all the wires that go in and out, And so because they look, basically they're computers inside out, they're analog computers essentially, people are aghast and amazed by the complexity which is visible. And they like that. Somehow that's an exciting aspect. And that's not to be deterred on any negative comments, but it's when you've got something which actually has thought about all of that and made it simple for a 10-year-old child, somehow people therefore think it's simple and not. They lose their ability to perceive its potential for expression.
Is there also this thing, I've heard this said by some musicians, and we've already talked about the fact that your ability to type goes to heck when people are watching, right? There's also, I've heard musicians say you lose IQ points the second you get on stage. And is there something about making a system that even a 10-year-old can grasp quite amenable to the brain that's standing on stage wondering what they're going to do next?
100%, yes.
Okay.
Yes, the cognitive load that is a fact of being in a stressful performance context is very real. So yeah, it's definitely losing IQ points. It's definitely losing dexterity. It's definitely losing focus. And practice, at least for me, is the only way out of all of that. And familiarity with the system, but also a system that is designed for the classroom where an error happens and you want it to be really clear to the user what the error was, and you want it to be really clear to the teacher who might pop over the shoulder and go, oh yes, there's the error, and that's the solution there. A system designed for that is also going to be great when you've had a few beers and it's midnight and you've got 1,000 people in front of you and you make a typo, because you will make a typo.
Yeah.
So Sonic Pi, I started to add functionality sort of halfway through its life, not just to do the teaching of computer science, once I'd realized that was actually pretty much solved and not really the hard problem. The hard problem wasn't, can you teach computer science? The hard problem was, how do you get the kids to care? How do you get the kids to be engaged? And so that was the interesting problem. And so, yeah, the music really helped that. But then if you've got a music system which is not very powerful or not very good, then that's crap. No one wants to play a crap instrument. No one wants to play the rubbish instrument. They want to play the good one. Yeah. And so making Sonic Pi more expressive and more capable as a musical instrument was both an interesting thing for me as an artist. Once I'd done that video for that arts project, and I decided that the simple was actually what I wanted, not the complex, and I essentially never touched overtone again. Oh. I was very happy working with Sonic Pi as my artistic thing, and so I was sort of increasing its artistic capabilities, and there were other bunch of artists working as well. But yeah, the kids also cared about that. They were like, well, why does it sound like, why can't I do this? And when functionality wasn't on the curriculum and wasn't possible, and you weren't able to teach it, that was actually an obstacle rather than a benefit. It's not like we've made this curriculum nice and sort of small in scope, and so therefore the stuff we can teach is good. Actually, the kids wanted to do the stuff outside the scope because that was interesting to them.
Yeah.
So how did you make that something you could do whilst not actually interfering with the basic computer science sort of concepts you were teaching? So that was always an interesting challenge as well. So not just how to make it simple and complex, but how do you sort of pull the wool over the teacher's eyes so they don't realize they're teaching concurrency? But that's what the kids want. They want to play the drums at the same time as the bass, obviously.
Right,
you want to add reverb, you want to add distortion, you want to do lots of cool stuff that wouldn't be necessarily on the computer science curriculum. So adding all those concepts in a way that didn't disrupt the classroom also made them cognitively simple, and then therefore when I'm performing on stage and others are performing on stage with the system, it actually works much nicer. It's much easier. But with overtone, I was always so stressed when doing a performance. Is it going to work? Am I going to be able to get it working? Is it going to boot? Is it going to, if there's a problem, how am I going to fix it? With Sonic Pi, it was just, it's just going to work. It's like I rock up with my guitar, pull it out, as long as it's in tune, I'm good. Yeah. And I wanted an instrument that had that sort of didn't have to be scared every single time I performed. And Sonic Pi does that.
If 30 kids in a classroom can get it running reliably, then you can at a gig, right?
Absolutely, yes.
Okay, so I think we have to dive under the hood into how this works.
Sure.
Right. So if I wanted to build a live coding music system from scratch, what big problems would I have to know about?
Well, I think that you'd have to have an idea of... I mean, I'm a firm believer that you shouldn't just build a system for the fun of it without actually having a use case.
Okay.
So, I mean, for the fun of it, with an actual goal in mind. I want a system that does this. And either you're the user that's going to work with it, or you're going to work very closely with the user that's going to use it. Ideally, you're the user. That'd be the best. But work very closely with the user. And then build the system really quickly and then get using it as quickly as possible. So bootstrapping it into something that makes something work. And then iterate and iterate and iterate. And so in order to do that, I think you need to have an idea of what kind of music you want to make, what kind of musical abstraction you want to think in, that maybe that's what you already think in. And also, I always invite people, especially when they talk about Sonic Pi, they say, I would like it to do this feature. I always say, can you let's not think about it other than just do a code sketch. Just write down on a piece of paper the kind of code words you'd like to be able to write in a performance situation. And then let's see if that makes any sense. So start with code sketches. Just sketch the kinds of letters, symbols, combinations of them. Do you want to use full English words? It's important to me, for example, when I'm performing, not just that I can express myself, but that the audience can have an understanding of what I'm doing. And so I chose not to have a language which was very terse and single letters like a regular expression, which would be much faster to type and faster to symbolically manipulate, but would be totally impenetrably unreadable to the audience. But maybe that's what you want, right? And so having an understanding of what kind of level of abstraction of semantics and syntax, who's the audience? Is it you? Is it others? Are you projecting it? Are you aiming it for others to be able to easily learn it or easily work with it? Or are you just building it for yourself? Are you building it as a system that's not going to be used in terms of written frequently, but you're just going to want to express a sort of artistic installation and just have it running? All these things would really change the kind of language that you would create and work with. And then, of course, you then want to think about what is the sound that you're producing. And so I think I'll be super interested if people have any other ideas, but the three categories that generally happen are, well, maybe it's four. Maybe you've got like just normal acoustic instruments you're working with. So you're just taking audio streams into the system.
Like your data coming in from a microphone. Yeah,
exactly. Microphone or like electric violin or a synthesizer or something. Or you're triggering those directly using some protocol like MIDI or Open Sound Control programmatically, or you're generating synthesizers in real time. And if you're doing that, are you either doing it in a web context or a non-web context? Because the two main sort of systems that I think are worth spending time looking at are web audio for the browser, which is a phenomenally sophisticated synthesis engine that surprised the heck out of me when I started playing with it. It's really, really capable. So
the HTML5 spec includes a decent synthesis engine.
Unbelievably powerful synthesizer. Yeah. Unbelievable. Yeah. Okay. There's some lacking bits that I miss. There's no way to observe when a synthesizer you create is completed. There's no sort of callback mechanism. But the timing's there. There's a whole bunch of different synth nodes you can use, and you can link them together to create large graphs of synthesizers, which is very much similar to SuperCollider. And if you're doing it non-web based, I would push people towards SuperCollider, unless people have a very specific style of synthesis technique they want to explore, in which then they're building their own synthesizer. That might be what you want to do. But if you just want to work with an existing one, SuperCollider or web audio, and then pick a language. Or design your own language, whether it's a DSL, so you're taking a language like I did, like Ruby, and you manipulate it, or do it with the Lisp, or you build your own sort of parser and work that way. Yeah.
Okay. I'm surprised that in none of that you didn't mention like timing and concurrency and scheduling.
Oh, that's a very good point. Yeah. So well, of course. I think that with all those things, it depends on what you're trying to do. So Yeah, I think that. So they're critical. You can build a good. So it depends what's driving the timing. So if you're using SuperCollider or Web Audio, then they have a sense of time. So all you need to do in your language is to say, at time t, I would like to play this note, trigger the synthesizer, modify the synthesizer, change its amplitude to be louder or whatever.
Okay.
And so all you need to do is to need to build a system that is able to manage a concept of time. So it doesn't have to be performant. It doesn't have to be executing sympathetically, temporally, in time with the things. It just needs to be able to run alongside in human time and have a accurate notion of when the time is.
So you're offloading you're offloading real-time computing to the service to
entirely. So Web
yeah.
Audio has its own scheduler, and it has ID. Yes, it does. I mean, I'll talk about another time, but there are other issues to do. But generally, Web Audio, you can send a message with a certain time, and it will trigger that synthesizer. And SuperCollider also has extremely well-timed scheduler built in. So yeah, you're using that. I mean, if you want to do MIDI, for example, then you have to build your own scheduler. MIDI doesn't support that, so if you want to be able to. Or if you want to be able to work with visual software and do some VJ stuff and send messages to control VJ software, then again, you'll have to write your own scheduler. So it depends. If you want to stick simply, then just work with SuperCollider Web Audio, use their scheduler. And then if your language has... I don't think you need the concurrency stuff, really, for a very simple, fun little language that's extremely expressive. I just want to do all of those things I've described. I want to do all. I want to do audio in, audio out. I want to do MIDI in, MIDI out. I want to do network messages in, network messages out. I want to control Web Audio, and I want to control SuperCollider. And I want to do it all at the same time. And I want to be able to take MIDI events into the system and then use them to modify synthesizers and Web Audio. And so I need lots of threads running. I need a thread-safe, deterministic, coordinated state system that can work across all of these different things. So if you're building a thing like that, then I think that then concurrency becomes really, really critical. But if you're just doing a basic thing, you don't. Like the first version of Sonic Pi, just a few threads, that's fine. Like it's not really, it's not hard. It's when you're doing the live loops and the timing of that you start to care about that, because you want to be able to coordinate things like stopping any threads that are created. But only if you're making a system that lets you create lots of threads arbitrarily. If your language doesn't let you do that, and it manages the threads for you, then yeah, you don't really need sophisticated concurrency.
I'm going to pick you up on that term, though, because I know you've mentioned this a few times in the past to me, and I know it's a critical idea. Live loops.
Yeah, so in Sonic Pi, that was the way to do concurrency. And so loops were on the curriculum, concurrency wasn't. And so a loop obviously has no concurrency semantics typically. It's just a black hole for a thread. Yeah. Once the thread gets into that loop, it just stays there, just spins around forever and never gets out unless it's got like a break inside of it or something. Yeah. And so, but the kids wanted to do a loop with the drums and to do a loop with the bass. Right, that's what they all wanted to do. Within a couple of hours, they were all doing it. And it was like, putting the hands up, how do I do the drums at the same time? The bass, so you can't. And they were like, that was one of the examples where it was clear to me that a system which was just designed to teach the curriculum wasn't going to cut the mustard, because it wasn't what the kids wanted. It wasn't engaging them. You needed to be something a bit more magical than that. And so
I've got to ask, though, before you carry on, how come you hadn't already crossed that path in your own coding?
So this was with Sonic Pi. In Overtone, I was using...
you were still on Overtone in those days?
Yeah, I was using a concept that came from a really nice Australian chap called Andrew Sorensen, and he created this idea called temporal recursion. Okay. So it's like a recursive loop, which is a scheduler built into it. So it's like at the end of the recursion, you call yourself, but with a new time to thread through.
Oh, okay,
And then you use that timestamp to then, as the timestamp to schedule the things. So in the case of SuperCollider, that was the timestamp you passed to say at time t, trigger the synthesizer, and then the recursion would schedule itself in the future. So it would be roughly just before it needs to happen, and have a fine timestamp that is accurate, like a virtual or logical time.
Right,
so we're using temporal recursion and overtone, and obviously then trying to like throw temporal recursion into a computer science lesson for 10-year-old kids was definitely not something that the teachers were going to be happy with doing, even though not actually that complicated, just fancy words. But a loop which happened to look just like a normal loop. The teachers didn't realize it was a special kind of loop. So in Sonic Pi, it's called the live loop because it sounds cool. And the teacher's like, fine, it kind of ticked off the curriculum loop. But it also happened to have the ability for concurrency to happen. So the live loops all operated concurrently with each other. And also, in addition, the live loop supported live hot swapping of their functionality whilst executing. So you could modify the contents of a live loop, hit the run button, and the next time around the live loop, they would use their new behavior. So you could start them off doing a simple thing and then keep evolving it, which is the kind of like what the temporal recursion also had, because you could say, next time I schedule myself, here's the new function to execute.
Yeah.
And so that made sense. Like I just took that idea and made it into a more usual looking concept, a loop.
This is sounding a bit like a couple of concepts that I bet you couldn't get through the curriculum either, but it's sounding a bit like functional reactive programming and a bit like actors.
Okay. Functional reactive programming, where you've just got like chains of functions. I mean, weirdly, functional reactive programming is much closer to the music world. A lot of music systems are actually functional reactive programming.
Okay.
Have like big graphs of boxes and lines, and the data flows through them. And actually, that's how SuperCollider synthesizers are designed. It's kind of like functional reactive programming.
Okay.
And the other one, actors. Actors are obviously always running. I mean, like an Erlang actor where you send in messages. Live loops don't allow you to send the messages. They do read from a global state, but that global state is deterministic, so it's kind of like a message box. And it turned out that actually, the concurrency abstractions I had to design in order to make this stuff work and work effectively and well turned out to be a sort of crappy version of Erlang's Beams OTP stuff. It just didn't make. And when I met Joe Armstrong, who was the co-creator of Erlang, it was interesting to have a conversation because a whole bunch of things I sort of had to invent in order to make this stuff possible were already clearly part of OTP for many, many, many years. And so it was quite an interesting set of conversations to discover that overlap and to realize that I had kind of invented through necessity stuff which had already been invented through other necessity of building a telecommunication system. So it is interesting that these concepts kind of like they're there, like mathematically, they're just like there to be discovered rather than.
Yeah. This is why some of our concepts end up sort of overlapping and looking similar, because there's almost like there's some fundamental shapes out there that we keep rediscovering.
Yeah.
When you hit that point, were you at all tempted to kind of move to Erlang?
Yes, very much so. And in fact, I'm doing that now.
Right. Tell me about that.
Yeah, so more like the concurrency stuff inside Sonic Pi works, but it's got to a complexity now internally that there's too much technical debt really to easily modify it and keep it going without really requiring large chunks of it to be rewritten. Because as I was discovering the concurrency abstractions I needed, I was implementing them and kind of like exploring them whilst I was implementing them. So they kind of changed shape and they ended up into sort of a weird thing that if I were to re-implement them, they would be much more clear and simple. But also they baked in the domain so they weren't like with Erlang's OTP, these concurrency things are abstract of the domain you're working with. You take it's like a function is a thing you can apply to any kind of programming language. But these are kind of functions that were baked into my musical concepts. They were like woven together. Right. So I need to unpick them apart to then be able to work with them more effectively. And that's just a huge amount of work and would leave things to be very broken. And if I'm going to do that much work, I may as well move to another system which actually has those abstractions that have been designed by engineers for over 30 years. Tons of work put into it and really tested and really worked well rather than building my own stuff. So yeah, moving to Erlang makes a lot of sense. And that's the path I've been looking towards doing. But of course, if you've got a system which has got a lot of traction, a lot of users using it, a lot of schools are using Sonic Pi, the language was well supported, like ChatGPT understands it. So there's obviously a large sort of corpus of Sonic Pi tracks out there for it to learn from. Yeah, moving to another language is non-trivial at this point, but it's nevertheless something I'm planning on doing. So I did spend all my time moving as much of the internals to Erlang as possible. So all of the input-output infrastructure, the I/O, and the messaging infrastructure, the scheduler as well. These are all implemented in Erlang.
Today?
Yeah, today, yeah. So Sonic Pi contains Ruby for the language, C++ for the GUI. Still got the synthesizer still implemented in Clojure, although that's not part of the runtime. That was used compilation. And then Erlang for the I/O stuff. Yeah, and then SuperCollider for the synthesis. Yeah,
I'm surprised if you can get that running on 30 kids' schools' computers reliably.
On Windows, yeah.
On Windows, yeah.
Yeah, as an installer, yeah. So it works well, surprisingly well, actually.
Really?
Yeah, it's just a lot of effort to actually figure out how to package it all up. But once you've done that, it just works well. Yeah.
Okay. And then have you not just created problems with getting different subsystems to communicate with each other?
Oh, it's a nightmare. Yeah. Okay. It's like all the problems you have with microservices. Essentially, I've baked into my application. So I just brought those problems in. So having to be able to reliably start all those processes up in the correct order, to monitor that those processes are running. If one of the processes crashes, you don't want it to zombie the system, so you have to observe that. So I have monitoring software I've developed. And that was also a pain to get that working similarly on Mac OS and on Windows, which then starts all the processes up, monitors and maintains it and watches it, and then runs in the background. And you have the GUI talks to it every sort of 10 seconds to say, I'm still here. And if the GUI crashes and it doesn't send a message, and there's like a kill switch happens, and then it just shuts down all the programs. So it's like designed to shut down unless you keep it alive. And that way... Yeah.
That seems terrible for live performance. I mean, terrifying for live performance.
As long as it's working, it's fine, right? So, but yeah, so if you've got a crash, right, you want it to all die properly. And so as long as the system doesn't crash, then you're good. And so that's about, is the program reliable enough not to crash? And so that it doesn't. I've not ever had it crash on me for many years now. Okay. If you make a bug in the program whilst you're running it that's within the runtime, then that's a different matter entirely. That won't crash the system. This daemon thing won't come into existence. That's only if there's some C++ pointer error, and you can't read the memory, so you get a crash on that kind of level.
Okay.
Yeah.
I have to say, you describing this monitoring and observing and restarting system, that sounds like yet another part of Erlang you've reinvented.
Exactly.
Okay.
Yeah. But on the process level. So it's more like a really crappy mini version of Kubernetes. But I'm not monitoring containers, I'm monitoring processes. But it's a similar kind of concept, right? Like you want to be able to observe all the things you've created, to observe the order that they get started in, to make sure they're all running, and to have a safe way of making sure you can tear them down in a correct way. Okay. So it does all that kind of stuff. Yeah.
So what will the future version look like? How much of that will be Erlang?
Yeah, I think that's one of the biggest, in terms of where I'd like to go, I feel like I've got a really nice expressive language. It's beautiful to work with. I love live coding with it. There are artists around the world now performing with it, and it's beautiful to see. So I'm really happy with the language. But there are there's two sort of key things I really want that I can't easily do with what I've got currently. Okay. One is drastic innovation of the graphical user interface. So this thing is in Qt. It's really slow for me to develop and modify and change and to try new ideas out. And I have loads of ideas I want to try out to see if I can make the experience of both teaching computer science with it, but also as an instrument. And mainly they're around giving more feedback, like visualizing what the computer's doing in a useful way. Oh, okay. So kind of like a live debugger, I guess, but more of an instrument. So there's more those kind of aspects I'd like to explore, and also integrating things like visuals. I want to be able to perform with Sonic Pi and not have to bring in external visual systems. I want Sonic Pi to be able to be the visual system as well as the audio system.
Oh, you just
So
want an
like a full-
HDMI cable out from your laptop to the giant LED
Yeah.
wall behind you.
Yeah, in one process, one programmer to install, and that's the one thing that kids can play with and the one thing it can perform with. The moment I've got like a complex setup where I'm using professional VJ software and a mixing software and NDI to take video, there's a lot of stuff I've done to make it work, but I'd like to be able to somehow bake that into my free open source application. And then the other thing that really is holding me back is that I want to build a platform that lets the world collaborate and create compositions together. So Sonic Pi is a really nice language for composing and for performing, but it doesn't lend itself well to sharing your compositions because you're effectively sharing code which can contain all sorts of nefarious elements with it that are getting evals directly on the machine. So it's the same problem as don't ever run a bash script where you're just grepping, so you're curling from a URL, some random bash script, and running it on your machine because you've got no idea what that script is doing.
Play the kick drum 4 times and then delete the hard drive.
Precisely, and because you can shell out to the terminal, you can totally do that. Yeah, like install this dodgy software on my machine, install a key hack thing, whatever. So this is something I've always avoided is creating this online sort of corpus of compositional elements, full pieces and data riffs, as I'm calling them, or a little bit of abstractions of parts of code, of parts of pieces, because I don't want to have the responsibility of making sure all those things are safe. So I want a language which is by design safe. And that's not Ruby, and it's not Erlang, it's not Elixir, it's not Haskell, it's not any tradition, it's not Python, because all those languages don't really have a good, solid sandbox to say, I'm only going to allow this part of the computer, this part of the language to run, and it can't talk to the disk, and it can't talk to the network, and etc.
Right, yeah.
So the famous language which does this is JavaScript, obviously. That's designed to run other people's code on your machines. That's what you do whenever you go to a website. So that's an obvious choice. But I also want to explore the idea of collaboration. I want to be able to I've heard about the old software that allowed people to jam together remotely. So it would essentially send, not the audio, because people can do that. It's like having a Zoom jam. I don't mean that. I mean sending the events. Like I've pressed this keyboard trigger, or I've run this code, which is triggering these notes. I want to send those events over to another machine on another part of the world and have them generate the sound. And I also want to run little small algorithms, like little live loops, and send those over to the other side of the world. So I'm not having to send all the events. I'm just sending the code which generates the events and have that run on the other person's machine. So that's kind of like a sort of continuation of something that can be transported. So I want those things. And so in order to do that, it seems like an interesting approach is to have it all running in a central cloud computer, which then can coordinate all these multiple computers together to create collaborative jamming sessions, a bit like having chat rooms, but jamming, and then having a language which can run on that cloud server that is it won't allow the users to then hack the cloud server. So JavaScript is one approach. I could use that with something like Node.js or something. But I'm actually looking at using Lua because there's a really nice implementation of Lua called Luerl by Robert Verding, who's a co-creator of Erlang. And that runs in the Erlang beams because I want to try and get everything into Erlang because if I have one process, it just makes everything much easier.
Yeah, I can see that. And
so Erlang lets me, or Elixir particularly, which are both languages which run on this virtual machine called the Beam. I can do all my I/O stuff for I already do with Sonic Pi. I can also then generate events to then be sent to the synthesizers. So that could be SuperCollider or it could be web audio. So I've already built a prototype with the University of Sheffield called Bleep, which is exactly this, which is an Elixir web app that runs on a server, which then uses the browser as the GUI and also the synthesizer. And it's sending all the events of what to play and when to play with the timestamps that we talked about before across the wire down on WebSockets. So that seemed like a really nice approach to work with. And then I can coordinate all those things. So if I have the code running on the server in a sandboxed environment, I can effectively then send code to be run on that machine to then send all the events to everybody else, or I can then relay the code to be put on other people's machines locally. There's loads of opportunities where your code is essentially can be moved around to the most sensible, logical place, and then you're firing events from that place.
And Lua can be effectively sandboxed like this?
Entirely. I mean, it's designed to be sandboxed, so it's designed to be a hosted language. It's used a lot in the gaming industry, so you can easily sort of chuck it into a C++ app, and you can then, and it's really nice to have bidirectional comms between the language. So you can expose functions to Lua. You can also call Lua from the host language as well, bidirectionally. And the Lua implementation is really nice because it has this interesting property where you essentially create a data structure in Erlang, and that represents the Lua virtual machine as a data structure, which is like essentially an empty computer almost with memory, which you can persist and you can load it back up again, and then you can then inject some code into it, and then you can run that code, and then you can then inspect what values there are in it, and then you can persist it and you can load it up again. And so you can, and then you can clone it and you can do all things with different ones. And as it's executing, you can say to it, when you call your Lua function, actually you're going to call this Erlang function or this Elixir function. So that's a way for the Lua to call out to the system, and you get to control exactly how that happens and where, and so that you can maintain the sandbox nature by making sure those functions are sound and safe themselves.
Oh, so you as the Lua host decide which lower level functions it has access to, and you don't give it shell access.
Entirely. I mean, so like in Lua, you get essentially a table. Everything's the key value pair tables, even lists. Weirdly, this is one of the annoying things about it. Key value pairs where the keys are integers. That's how they do lists. But the function tables are the same kind of thing, and you can just remove the functions which do the I/O and remove the functions that do disk stuff, and just take them out. Okay. Remove the functions that can do system calls, and so that your virtual machine literally can't do that anymore. And then you can say these are the functions which are mapped together. When I call this Lua function, I'm actually calling this Elixir function, and you implement that and you control what that does. So that's maybe sends a message out to the browser to say trigger this note. And then you have that complete control. That's our sandbox nature. It's really nice.
Okay. Yeah, I could see how that you could then make that safe for both musicians and kids to collaborate.
Yeah.
Writing.
And once you've got that, then you can build this huge corpus of people of music that people can share and jam with each other, and it's going to be a beautiful thing.
Yeah, I can see two problems that you must have thought about, so I'm going to ask you. One is latency. As soon as you're going over the network, like music, I know a musician can cope with about 10 milliseconds of latency, which probably doesn't even get me to France speed of light, does it?
No, probably not. No. I mean, actually, musicians can cope with latency just fine. That's what an organist is. They can cope with 2 or 3 seconds of latency. When they press their key down, the wind builds up in the bellows, comes up to the pipes, and then they hear the sound. So latency is not necessarily, I mean, it's not ideal, of course, but latency is something that musicians can deal with if they're trained. And so that's what part of an organ scholar's job is, not just to learn how to play the notes, it's how to play the notes ahead of time. And somehow be playing in time when the sound is coming multiple seconds after you've actually triggered the notes. Right. The hard part is jitter. When you press something and it's a random amount of time after you've hit it, that's something you can't deal with, and that's makes everything just sound rubbish and drunk and terrible.
That sounds like the internet. Both parts, actually.
Yeah. So, but both of those can be, well, certainly the jitter can be obviously always dealt with in the same way that a video stream or the fact we can talk to each other now with adding latency and having a window. And so that if the messages come out of order, slightly out of time, you're still reading them in at a sort of sensible sort of periodicity. And so by adding latency, you can cope with jitter. So the real question's about latency. With the first version of Sonic Pi, it was the machine, the original Raspberry Pi was so slow, I actually added by default half a second of latency from when the code got executed to when the events got heard, just to give the system some room to breathe.
Right.
And that was what I needed at the early days. And I've actually kept that all the way till now. So even though now I could actually reduce that down to tens of milliseconds, it's still 500 milliseconds. And no one has ever complained. It's never been an issue.
And you've played live with that a lot.
Absolutely, but because that's about the scheduled events. It's not about when I press a key, then I have to wait for that 500 milliseconds. So it's more about the system generating the events generates them 500 milliseconds ahead of when they need to be played. Right. That's okay. So it's only now we've reduced it from jitter to latency, and we're taking latency and actually reduced it down to it's only the immediate events you care about. When I press a button, I want to be able to hear that sound. That's the actual problem, and you can't solve that. So if you, as long as you're not doing, I'm playing the keyboard, I'm hearing the sounds, and I want everyone else I'm jamming with across the internet to be able to hear them directly at the same time as me, then you're okay. If you're just doing, I'm writing code, the code is making music, then you're fine.
Because as a musician, you're not really playing an instrument so much as you're queuing up a composition.
Precisely.
Yeah,
absolutely.
Okay.
And you can queue it up 500 milliseconds ahead of time, and that's totally fine. It feels immediately enough to work with. It's never really felt latent. I don't feel ever I'm miles away in the future. But when I press a key and I want to make an event happen, that is an issue. And Sonic Pi has sort of a cheat mode for you can put a thread into a real-time mode, and it won't add that latency. And so it does that real time. But that works obviously just fine on your machine when you're generating the event on your machine and you're hearing the event on your machine. If you're trying to then coordinate that event with others, that's not going to be so simple. But it would be possible if you're happy with a bit of latency for that to work. Certain kinds of sound actually, so we can actually reduce it even further. If you're doing very sort of synthy, backgroundy, droney sounds, the punctuality of it isn't that much of a problem. It's only really rhythmical things you care about. So even then, it's like a smaller subset. But then you could then imagine things like, I want to actually play it locally, create a data riff, a data structure, and then send that to be scheduled and played everywhere else.
Define data riff for me, because I love the term.
Oh, it's just a fancy word phrase I came up with. It's just really a time series data. So like at this time, do this event, at this time, do this event. And so...
Oh, okay.
So I'm imagining like recording like me playing the keyboard or twiddling some knobs or pressing some buttons over a particular window, recording all those events as a time series sort of data structure. It could just be JSON or whatever, right? And then giving that a name and then being able to then ship that across to others and for them to then plug it into their algorithms running the little Lua things, and then they can play the same thing I'm hearing.
Right. Okay.
So that would work perfectly fine. So I could create my data riff locally, ship it out to everybody else, and then say, at this time, go, and then we would all hear it exactly at the same time. Although we wouldn't hear it at the same time. That's actually not important either. We'd all be hearing it staggeredly different times. What would matter is that the relative timing of each note is the same across all performers.
So as long as we end up hearing the same composition.
That's all that matters, yeah. Because you're never going to... You've got the fact that you've got speed of sound is always already an issue. Like if you're over to the side of a football pitch and I clap my hand or tingle a bell, like the sound comes much later than the visuals.
Yeah.
So you can't get away from the fact that sound is always going to be at different times. But what you can do is make sure that the relative timings are all the same for all listeners.
So is there a future then in which you are collaborating with another live coder to play to an audience who are all like completely separate geographic locations as well?
So this is the goal, yeah. I want to be able to say to an event, hey, I'll do a performance. All you need to do is to open up a browser, connect the computer with the browser to a decent sound system and a projection, and then I will then control that browser remotely. And I can do it either myself or I will collaborate with others, and we'll work with our events and send those events to that particular browser.
Yeah. And all they need to do is hire the backing dancers.
Well, if you want dances, but yeah, just cool visuals and cool lights are probably fine. But yeah, I think that the ability to essentially control another browser through the web audio and through WebSockets, essentially sending web events and doing the visuals on the browser as well, I think is actually a really interesting space. And you can even do this when you're co-located. I'm totally imagining, because when I'm performing, for example, I'll want to see the code I'm writing on my screen, and I'll want to project that code with some cool visuals. And when the cool visuals are particularly going crazy, that might make the code slightly harder to read. And that's a compromise. Like it's nice to be able to have like some cool, fancy, flashy visuals a bit, and then the code be easy to read a bit, and then go back to the visuals a bit. And whereas if you just have the code all the time on its own, that can be a bit staid and a bit boring. But I do not want to see the visuals when I'm performing. Like I don't want to see them. Like they'll annoy me. I want to be able to see the code.
Yeah.
So there's a difference between what I want to project and what I want to see. So having a system that lets me control the browser essentially and composite a view for that browser, which is different than one on my local machine, would also be quite interesting too. So this would be the same kind of thing. If I imagine this performance with me and you, Chris, we're jamming together at homes, we would have our own unique view of what we're doing. I might have like a window of an aspect of what you're doing. You might have a window of an aspect of what I'm doing. And then we would then create a composite window of our combined performances to send to the performance venue.
Right,
we would make some choices about what we actually are. We going to send our code? We're going to send the visuals? We're going to send the events and so whatever the right approach for that particular performance. And being able to mix and match and work with a composite set of graphical elements, I think is a quite interesting place to be.
Yeah, and is there going to be someone separate just working on the visual side of the performance and all that stuff? Yeah.
Exactly. They just want to see their thing emphasized. So maybe they want a little window of what we're doing to be able to see. So when I perform, I do see my visuals as a small box in the bottom right. Yeah. So I can see it, but it's not interfering with the code. It's not making it hard for me to read the code, which is, for me, the critical thing.
Okay, so I have to ask you the other big collaboration question, which is like you're doing something with the kick drum. I decide I want to do something with the kick drum. Is it just a collaboration? Like, is it a race condition? Whoever got there last wins the kick drum? Or are you looking into doing CRDT stuff? Or are you just going to agree before the gig that Sam does drums?
Yeah, I mean, that's a very good question. And I think that the answer is yes. It really depends on what we want to do. I mean, is there only one kick drum? So, like, typically when I work with Sonic Pi, you can have as many kick drums as you want. And so we would just have our own kick drums and we'd just be kicking them, banging them away. And that would be totally fine. But maybe we want them to be in time with each other, or maybe we only want one kick drum. So these are all decisions to make as an artist about what the performance is and what the composition is. I think that in terms of like the broader question of coordination, in my mind, I have CRDT-like structures for dealing with time series of events that I want to be able to be generated independently, but always be able to be brought together in a deterministic manner. And then coordination happen off after I've made some attempt to bring them all together. What does it look like? And that's how I'll make decisions off of that. So bring the data streams together in a deterministic way, and then look at the weaving of them, and then make some decisions about that. So if we're both fighting for the kick drum, then there'll be some way to say, once we've sent our kick drum events, they get merged together, who clobbers who. And that will be part of the decision of the design of the system. And we might say, well, actually, you're in charge of the kick drum, but there might be moments when your mind is doing something else, and I want to be able to drive it. Yeah. But if you come back to kick drum, well, you should be able to take over from me, for example.
So like sort of soft locks on particular instruments.
So the way I see it is like if you've got two events which actually are operating over or creating the same kind of event, a similar kind of event. When you read, so about when you read it. So if you go into the data structure and you read an event, and there's two values in there which purport to be that event, you need some way of having the resolution, conflict resolution. Which one are you actually going to read? And so I think that needs to happen, I believe, for it to be interesting and useful across performances. That needs to be deterministic, which is like CRDT style, right? So you will have some way of saying, add a priority to each event, but if the priority is the same, maybe you want a timestamp. But if the timestamp's the same, maybe you want some just unique random UUID, and you alphabetically choose the one that's just first.
Some kind of tiebreaker.
Some tiebreaker that you can then always deterministically choose that one. Okay. And then, so if we care, like you're in charge of the kick drum, give your thread a higher priority than mine, and that's part of our programming language we're writing. It's not the tiebreaker. It's that happens at the end when everything's the same. It's something we can choose as artists.
Okay. Yeah, that sounds like fun.
Yeah.
So In that case, with a view to this whole system being rewritten this way, and the gig that we will do one day, 5 years in the
cool.
future, when we're playing Wembley from our bedrooms, how
I want to be
best...
at Wembley, to be honest. If we're in Wembley, I'd rather be
that
there.
one you're going to actually commute for.
Yeah.
So this raises the two questions. If I want to learn how to do this, how do I learn how to do it from scratch? And how do you even get good enough to live code on stage?
It's a really, really good question. I think ultimately you have to start by actually wanting to do it. That you need that drive to be able to put you through practice. Just like when you learn traditional musical instruments, you have to want to do it to put in the practice, to be able to get the motor skills or the listening skills or the performance skills necessary to be able to do what it is you want to do. So you need to be able to want to do it, and you need to have the dedication to practice. I think that's the same across all instruments, and live coding is no different. I think what you learn is slightly different, and how you learn it's going to be different, but ultimately it's that sort of desire to want to do it and the desire to practice and the discipline to do that. That's essential. So we're starting with that. And once you've got those things, I think really then it's about, with live coding, once you first of all need to choose which system you want to work with, right? So there's actually a whole bunch of them, some really cool other live coding systems around. So I would play around, just like if you wanted to learn an instrument, you might try trombone, or you might try guitar, or you might try piano, and then go, yeah, piano's for me. So similarly with live coding systems, there's tidal cycles, which is fabulous. There's Lang, which is a really nice little language. There's Foxstart. There's Impromptu. There's a whole ton of really cool languages. So go and explore the systems, find one you like, and then stick with that. And if that's Sonic Pi, the best way to learn it really is twofold. One is to work through the tutorial. So because it's designed for schools and teachers, it's designed to be super, super simple. So that's actually one of the advantages of Sonic Pi over other systems, is in the design of the system. It's not just a desire to build something that's expressive. There's also a desire to build something which is simple to learn. So that's one of the main reasons why I learned Sonic Pi. And it has a tutorial built into it, so I'd read that. I've also just created a course that you can buy, which is just starts you absolutely at scratch, which will teach you the very basics of knowing how to write code, what the code does, how to make a sound, how to play a sample, how to add effects to it, how to make a melody, how to make a drum pattern, and how to do your own compositions. That's the first course is that. But also just reading the tutorial will get you a long way there. So if you're a video person, the course. If you're a words person, the tutorial, or maybe you want to use them both. And then once you've got some basics down, the critical thing is, and another option is obviously find someone else. Someone else knows Sonic Pi or live coding system. Go and hang out with them, make friends with them, and learn from them. But once you've got it down, I think the critical thing then is how to get good at it. Is about putting aside any idea that you're going to make something that sounds good. It sounds counterintuitive.
Yeah, really.
So I think that the critical thing is that certainly with Sonic Pi, what you really want to be able to do is to be able to understand the semantics of the execution of the program. These are all fancy words to say. You need to understand what it's doing, what the words, how they translate to the sounds. Because once you've got an idea, once you've got like a very basic Sonic Pi interpreter in your brain that can read the code and sort of imagine the sounds, you can do something magical, which is you can imagine sounds and see the code. And once you get to that level, then you can do something really fabulous. You can imagine the sounds, you can hear the sounds you're creating, you can imagine the modifications to the sounds, and then you can use your brain and understanding of how the code works to then project out what the code is to write or to change to get to that place. So, and that's where you want to be. So I think to get to that place, you need to be prepared for it to sound terrible for quite a long time. And that's because instead of trying to make good sounds, you're trying to understand how the system works. You try to understand the logic of the live loops, to understand the sequential operations, understand how the different syntax elements work together, how the semantic elements work together. And you get a feeling for it. It's not just something you can just read and learn. It's something you have to practice and experiment with. And that's why it not sounding good is really important. You have to be able to write messy code, make messy sounds that aren't designed to sound good, but are designed for you to learn how it works. And the way I would do that is to always, before you press the run button, so you write your code, before you press the run button, try and read the code and imagine what it sounds like and see if you can hear it in your head. Press the run button, and then often you'll be surprised because you got it totally wrong. And then sit and figure out, well, why have I got it wrong? And then think about another change you can make, and then do the same again. If I make this change, surely it's going to do that to it. Press the run button. Oh, no, I've got that wrong again. And then perhaps make a smaller change. And then see if you can understand what that's going to do. And to the point where you do know what it's going to do, then you can grow yourself back from there larger and larger. Kind of like when if you're a programming person, you might have read about test-driven development. It's a similar kind of approach where you would write smaller and smaller tests until you've got one that you understand that works, and you can then step back and make bigger tests, and bigger jumps and bigger leaps of functionality. And this is really bigger leaps of cognitive understanding of how it works. So once you've understood how it works, then you can start to use it to your advantage. You can then, as I said before, you can imagine the sounds and you can see the code. That's where you want to get to. But to get to that first, you need to be able to see the code and hear the sounds.
Building up that kind of feedback loop inside your own brain. Yeah,
you'll be able to read the code, hear the code, and then you can see the code. And then that's when you're in a really interesting place. But this is like years worth of work, right? So that you're not going to get there straight away. So whilst you're getting to that, whilst you're putting in the practice of code reading, code understanding, code experimentation, I think it's really useful to also make it fun in certain elements as well. So it shouldn't all just be labor. And so a really great way to get bootstrapped and to make things sound fun to start off with is just to work with samples. Is to download a sample pack of a musical style or genre that you like. And there's a whole bunch of them out there you can buy for super cheap, like 20 euros or something.
These are pre-recorded pieces of like someone playing a flute riff or something.
Exactly, or a drum riff, or you can have like some kind of like heavy metal thing, or you can have some operatic thing, or whatever the style of music is you like. Yeah. Buy a sample pack of that. And then if you don't know anything about music and theory, actually that's probably a really good point. I remember meeting a few musicians now who are properly formally trained, highest level university music conservatoire type people who've all said the same thing independently, which is, I wish I could unlearn music theory. Which has always surprised me because obviously they dedicated their lives to learning it. But actually, often some individuals can feel that learning all the musical theory constrains them. They're only able to make good sounding music in terms of the defined definition of good. And actually, interesting music evolution comes from breaking those patterns and to doing things that aren't defined as good, that are just interesting and sound interesting.
Yeah, there's that classic thing, if you learn the rules to forget them, but forgetting them's hard, right?
Yeah, really hard. So if you're starting from a place where you don't know any music theory, actually, that's a pretty cool place to be. So, and all you need to then do is worry about making things that sound fun to you, because they'll sound fun to others. But as I say before, don't do that initially. That's the latest step. But if you want to get there quickly and you're not worried too much about learning lots of complex things, just making a live loop with some samples that you've liked, of the style you like, and mix them in and out. It's actually a really quick way of getting to understand the motor skills of working with multiple things at the same time and bringing elements out. So you just say you have 3 live loops, one with drums, one with bass, and one with synths, or one with vocals, one with guitars, one with bass or something. And then you can then switch out the vocals to another vocals that sounds similar but sounds different, or switch out the drums, switch out the bass. And just by doing that in and out, you can actually get to an interesting performative space really quickly, but also making music you like. And then, so that's kind of like working like a DJ, but working at the stem level, working at the individual level of a drum line or a bass line or a vocal line, and mixing those in and out. And that's really easy to do. All you need to do is change the sample name, press the run button, and next time around the live loop, it pulls in that new sample. And this is the next course I'm going to write. Actually, is going to cover exactly this. But yeah, that's a great way to get to an interesting place. And then you can start to then embellish that by adding your own little synth bits, or maybe you want to then slice the drums up into individual drums and rearrange them and use algorithms to deterministically randomize the drum patterns. And there's loads of cool things you can do that you can get to, but just simply playing samples of a style you like together at the same time, mix them in and out, gets you to an interesting place pretty quickly.
Yeah, that sounds like a lot of fun. I have to ask you then, on that, do you have a lot of plans for different video courses for different audiences? Because, like, you teach kids, you teach people who might know programming but not music. Presumably, you teach musicians that don't know programming.
Yeah, I mean that's a really good question. So I think that one of the missing parts of Sonic Pi is that there are people who can get started really quickly, and the tutorial built into the Sonic Pi really gets you there really quick, and the simplicity of the system also lends itself to just getting started, making your first notes. But then there's a whole void of people who just like, I don't know what to do. I don't know how to make it sound good. I don't know how to make something that's my style of music. But there are people somehow, magically, who have the persistence themselves to pop out of that and make beautiful, amazing things. And these are a growing number of people now who do some sophisticated performances. But they are quite rare. And so it's more about trying to make that pathway an easier pathway for more people. And so I think that's really about creating learning resources. And I think courses are actually a great way of doing this, for bridging that gap between I've just got started to here's where I want to be. I want to be able to live code a drum and bass track. I want to compose an operatic piece. And so I think there's actually different courses for different styles of music, as much as there are courses for very common used algorithmic musical structures that are going to be in your operatic piece and in your heavy metal piece. And then I think there's also probably an interesting set of courses for specifically teaching computer science, so taking the computer science angle and using music as the vehicle for teaching the computer science concepts for those who just want to like learn what a function is, what a syntax is, and what a algorithm is. And those concepts we can teach directly and using the music as an idea. But though I personally find that teaching Sonic Pi as a musical instrument and happily learning the computer science as a background is the better way to do it. Personally, I think it's much more fun.
Sneaking education into kids' heads.
Yeah, absolutely. Yeah, absolutely. Yeah, so I mean, if people have got ideas for what they would want to learn, so I'm going to do one. So I've got this introductory one now, which is a really nice way of just getting started to make your own first composition. And then the next, I'm going to work on one which is going to be specifically for performance. So this will be live loops. How do I play a bunch of things at the same time? How do I modify it as it's working through time? How do I take my samples from a sample pack? How do I play them? How do I make sure they sound the same? So the right key, the right tempo. What do those things mean? That's what you really need to know, those two words. And then how do I do interesting things with my samples? I just don't want just to play the same one every time. Maybe I want to add an effect, or maybe I want to reverse it, or I want to slice it up, as I said before, and do various really simple tricks that give you a lot of like creative possibilities. And my performances really aren't that complex. They're just lots of simple tricks I do at the same time, which in combination sound complex, but actually in isolation are really, really easy to learn. So I want to try and get to that point.
One musician I really like says 3 simple things put together sounds very complex.
Yeah, I can believe that too. Exactly. Yeah. I mean, I'll take a drum track, I'll take a bass track, and then I might take the drum track and not play it in its normal speed, but slice up into individual drums, and then randomly play one drum after another, and then do that in a way that repeats every sort of 18 or 16 bar beats, and then you get this pattern, and then you can change the seed and change the pattern until you find something nice. And tricks like that I can teach that really, really quickly. And you can use that same trick with a drum pattern and play the drums out of order. But you can also pass a bass riff, and you can play the bass hits out of order, or you can put a vocal track in there and you can play the vocal hits out of order, and you can get some interesting places very quickly.
I want to see that course.
Yeah, before Christmas, actually, yeah. Before
Christmas. What a great Christmas gift that would make for friends, family, and loved ones.
Oh, yes, exactly. And support Sonic Pi whilst you're at it. Because, I mean, we didn't talk about it at all, but it is important to quickly mention that being an independent open source developer is actually quite a tricky financial space to be in.
Oh, God, yeah.
And it's a shame, because I think that there are a lot of really interesting software systems that could be built that are in people's brains right now that are trapped because they're currently doing some sort of boring corporate job. And if somehow they could be freed from that corporate job and say, here's some finances to build the thing in your dreams, we'd have so much cool stuff in the world that we need to find ways to make that more possible. So, yeah, I think in general society we have a problem of how do we fund open source software, and specifically, I mean, because that's always an interesting question. how do you fund open source software which doesn't have a revenue as part of its goal? It doesn't, because I think there's a whole set of interesting pieces of software that could be created that aren't supporting business needs, but are supporting human creativity or expression or just joy and fun, that don't actually sell things, but are just there to be fun. And I think that they're the hardest pieces of software to fund because they don't have their own revenue model to support them, or a business need that says, okay, if we don't fund this open source software, we can't deliver our business goals, so we're going to have to siphon some of our profits to keep this going, or we'll put some of our developers on it. So I think that's an interesting problem. So I'm using the courses currently and Patreon, which is a way people can just donate money if they like what I'm doing to support the work I'm doing. But I feel like there's a real interesting problem to solve, that if we can solve it, there's going to be a whole ton of exciting pieces of software in people's minds that can be made into reality. What is your Sonic Pi?
Yeah, I think we absolutely have to do that as a society. And it doesn't have to be so much money. It doesn't have to be like $100 million of venture capital funding.
For one developer, yeah, exactly. I'm able to somehow. It is a disaster, really, but it's kind of possible to survive on my own from donations. The courses now I've just made, they're propping me up. But I do gigs and performances. So if a company wants me to do a party, I can do a Christmas party, I can do a corporate event, I can do a speech, I can do a keynote, I can do a workshop. And I've
seen you play the after party of 3 tech conferences. And
how was that?
Absolutely fantastic.
There we go.
You're the best tech. I don't know if you want to be limited to just tech conferences, but you are the best tech after party going.
Oh, that's kind. But tech parties are good because actually the audience has an insight of what I'm doing. And because the code is written for schools, it means that people who can program but haven't ever seen the language I'm using still can actually participate and get involved and read the code that I'm projecting, which is a really nice thing to be able to do. So tech audiences it's a bit more easy win. I have done a gig for a corporate environment where some people came up to me and asked me, can you play the Spice Girls? No, I can do some more drum and bass, or I can do some like cyberpunk industrial beat sounds, but I don't do pop music. So that's a clear misunderstanding that I'm not a DJ that has some decks that can just put whatever they want on.
Oh God. So education needed all round.
Absolutely, yeah.
Okay. So you need to give me, before we go, you need to wrap up and give me a special undiscount code where people can sign up for your course and pay slightly more because the average programmer can afford to support you.
I've made them really cheap, actually, and I think that's because I want more people to be able to do this. And to be honest, that's the exciting thing, to see the world learn to understand that code is not just a tool for business. It's a creative force that's yet to be really realized, and that music is one way of exploring that. And the more people we can get coding music, the better, I think, for society, just because it's just more people expressing themselves and more people having fun. Yeah. And there's obviously lots of other things you can do to express yourself and have fun, but I think coding music is a really interesting one. So making the courses cheap is a way to try and increase that audience and to get more people having fun. But if you do want to pay more, then just join me on Patreon if you like what I'm doing. Or if you're a corporate entity that wants to sponsor, you want your corporate logo on some things, I'm happy to talk to you. But in general, my goal is to try and make sure Sonic Pi and all the work, this new thing I'm talking about, this Erlang thing called Tau 5, to make sure they're always free, they're always open source, that you don't have to be rich or wealthy to be able to get started and explore programming. You don't have to be super smart. You don't have to have tons of background knowledge. You can just get started with the simplest, cheapest computer and install something really easily and have fun. And then if you want to do fancy, you want all that equipment I got behind me, sure, that's cost some money. Although actually one of them was a gift from Moog, but that was kind. But you don't need any of this stuff, right? You just need the Raspberry Pi, the cheap computer and a TV, and you can get started coding your own music. But in order to make that possible, to keep that free, I need somehow to pay my bills. But luckily, that's not the same bills as a large corporate entity. It's just an individual developer.
Yeah. You can keep feeding our souls. We need to feed you food. Something like that.
Buy the course, yeah.
Buy the course. And if anyone from Coca-Cola is listening, put Sam in an advert.
Hire me for your tech events. I'm pretty good, actually. I mean,
you really are.
I played at the Royal Albert Hall. plug my
Have
own
you
stuff.
really?
Yeah, that was amazing.
I didn't know that.
With a quartet of 4 young kids alongside it's like a whole room of, well, a whole Albert Hall of kids performing. It was super fun. So lots of traditional instruments like violins and cellos and guitar bands and drumming circles, and then this quintet of live coders and the teacher and me. It was great fun.
That's mad. And you've been reviewed by Rolling Stone.
Oh, yeah,
well,
that was
right?
true. Yeah, I was at the Moog Fest. That was like 2017 or something. Yeah,
That's quality.
yeah. They said I transcended the present, along
Right.
with Grimes.
Before before this turns into the Sam Aaron fan club, which I could happily join, I'll say thanks very much for joining me and taking us through it, and I wish you best of luck with the future courses.
Thank you so much. It's been a pleasure talking to you. Really a lot of fun.
Always.
Thank you.
Cheers, Sam. Bye. Thank you, Sam. If you want to get hold of Sam's software, Sonic Pi, you can download it for free. I'll put a link in the show notes. There's a tutorial built into the software, but if you want to support Sam and get him to teach you step by step, there's a link to Sam's course in the show notes too. I've bought a copy and I'm going to happily go through it over the holidays. I don't expect to play this year's New Year's party, but who knows in the future. And lastly, Sam's contact details are in the show notes as well, should you happen to be organising a tech conference and want a really great after party. Before you go and start coding up your first album, if you've enjoyed this episode, please leave a like, maybe rate it, maybe share it with a friend or a social network. And make sure you're subscribed, because we'll be back soon with another less musical but equally harmonious developer's voice. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Sam Aaron. Thanks for listening.